All right, so let's look at this one, and hopefully there's no background noise. I am in another um, Zoom meeting, so I don't know. Hopefully you can't hear that. All right, so today we're going to be looking at, oh, not this one. There we go. We're going to be looking at uh, determining whether two functions are inverse functions of each other. Now, we can determine whether two functions are inverses of each other by doing the composition. So if the composition of f of g of x and g of f of x, so both ways, if you do that and you end up with x for each one, then they're gonna be inverses of each other. All right. So f of g of x and g of f of x have to both equal x. All right, and we're going to see those, so don't worry. This in the notes. All right, so let's look at these. All right, so why don't you try number 27, and then I'll do number 28 here. Okay, so for the first one we want to do is we want to do f of g of x first. All right, so either way, any way we want to write it. So again, remember, we have our f of x, and then we have our g of x. So you want to start off with your f of x first. That's one on the outside. So 4x, leave some space because we're going to take away that x, plus 9. And now we're going to take away that x. And we're going to replace it with our g of x, which is x minus 9 over 4. So here, when we multiply this, notice that we have a 4 on the top and a 4 on the bottom. So because of that, they cancel out. And we get x minus 9 plus 9. And negative 9 plus 9 is going to give us 0. So we end up with x. Yay. All right, now let's do g of f of x. All right, so now this time g is going to be on the outside. So that's why we put that one first, x minus 9 over 4. And now let's erase that x, replace it with the 4x plus 9. So I have 4x plus 9 here. And the plus 9 and the minus 9, they cancel each other out. And we get 4x divided by 4. And the 4's cancel out. And what do we get? We get x. Ta-da! And they both work. So they are inverses of each other. Yay. All right. So we have that one. Let's try one more. Uh, let's do 30. If you want to, you could try 29. You don't need to. No, I didn't do these ahead of time, so hopefully I don't mess up. All right, so this is 28. And let's do 30. All right, so let's do f of g of x. So we're going to start off with the f of x. So let's start off with x squared. No, let's leave some space. Uh, over 4 plus 8. And notice our domain is x is greater than or equal to 0. Okay, and we're going to take away that x. And our g of x is square root of 4x minus 32. Now the square root and the square, they cancel each other out. They're opposites. They're inverses of each other. And we get 4x minus 32 over 4 plus 8. Now this one, it might look a little tricky, but then whenever you have this big fraction, okay, and you just have one term in the denominator, that's nice. And usually you want to break up that fraction bar. So we're going to break it up into terms. You can only do this for the numerator, okay? So here you have a 4x and a minus 32. So let's break up our fraction bar. Here we go, 4x over 4 minus 32 over 4 plus 8. And 4 divided by 4 cancels out. We get x. And 32 divided by 4 is 8. And plus 8. These cancel out. We're left with x. Yay. Check. All right, now we're going to go backwards. I'm going to put it on this side over here. Hope that's okay. So let's do g of x, g of f of x. All right, so this time we're going to start with the g. So we start with square root of 4x, leave some space, minus 32. And I'm going to change that x to the f of x, which is, so parentheses, x squared over 4 plus 8. So you have to distribute that 4. So distribute the x squared over 4 and the 8. All right, so when you do, you end up with 4x squared over 4 plus 32 minus 32. Its 4's cancel out, the 32's cancel out. We're left with square root of x squared, which is just done x. And it needs to be greater than or equal to 0 because of this radical here. Okay, so because of that radical, it has to be greater than or equal to 0. I know you don't see a radical in the final answer, but as long as it's there sometime, then there you go. So x has to be greater than or equal to 0. Okay, that is it. And yeah, so that one worked out as well. So if you want to try 29, feel free to. And if you want to look at any of the others, just let me know and I can do those. We can do those in class. I'll put these on the notes. All right. And then I did want to show you graphing. So this is the last thing that I'm going to show you. So how do you, because this is something that you're going to see on a placement test. Pretty sure you're going to see like one or two questions like this. They want you to graph the inverse of a given graph. Okay, the way you do that is first you have to the um, graph the y equals x um, line. And usually it's dotted. Uh, I'm going to use a solid line, okay, in the future because it'll be neater. Okay, but this is y equals x. You always want to reflect it over y equals x. And then the way you do this is you want to find some points on your graph. So right here, this is a good point. And yeah, this one right here, that's a good point. This one right here is a good point. This one's right here. You don't need to do all the points, but yeah, whatever. Just like one or two, whatever. Okay, now what you want to do is you want to make it perpendicular. So for each of those lines, for each of those points, you want to make a perpendicular line to that y equals x. Okay, so it's going to be going diagonal the other way. And that one is probably too far. All right, 1, 2.5, a half, 1.5, 2.5 right there. Okay. So remember to reflect it, it needs to be the same distance. The reflected point and the pre-image and the image need to be the same distance. So this is one space, and this has to be one space. This is 1.5, half, and a 1. 1, 2, 1, 2. 1, 2.5, 0.5, 1.5, 2.5. Ta-da! And there you go. And that is how you find the inverse. And you can write that as y equals the inverse of f of x. That's it. All right, so try 39. All right, and we'll do some more. Don't worry. Um, yeah, 40 is going to be interesting. Um, 41, not too fun. So why don't you try 43 next? And then I'll do 40. Okay, so I'm gonna use a solid line for the line of reflection, that y equals x. All right, so notice that it goes up one, right one, up one, right one, up right, up one, right one, up one, right one, up one, right one. Okay, so that's a y equals x. That's what y equals x looks like. All right, and then look for 2 points. Oh, maybe I should write the steps. Draw y equals x, line of reflection. Find some good points and then reflect those points. Same distance. And up one, left one. Okay, instead of up one, right one, up one, right one, it's up one, left one, up one, left one. That's the that perpendicular one. And I just connect your points. And that's it. So here, look at some good points. Are these points here? I don't know. They're pretty close, close enough. Actually, I'm gonna put one here. Yeah, I'll just put it there. Now it's not actually on the y-axis, but I'm just gonna put it anyways. Why? Just because. And here's a point right there. All right. Now that's not gonna give us the best, but so I'm just gonna get one here, and you'll see it. You'll see it. All right. So again, do vertical line, not vertical line, sorry, up one, left one. So here's 1, 2, 1, 2. So right there, 1.5, 0.5, and 1. Eh, 1.5, 5, and 1. And that's it. Those are our wonderful points. All right. And then connect it. So it's going to be really messy because, yeah, don't expect the best. Oh, 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 that's pretty good. All right. That's not bad. All right. So there you go. That's your y equals inverse of f of x. And let's try 42. So let's do one last one. Or maybe I should have you do, it's okay, I'll do it. Maybe we'll do this one later if you want to, okay? So yeah, that's it. So try it out and let me know how it goes. Yeah, let's see the others. Oh, I didn't save that one yet. Yeah, that's good. So let's stop there. And if you have any questions, just feel free to ask.